Okay, so we are going to talk about factoring the greatest common factor out. Keep in mind that the greatest common factor is the highest number that goes into the numbers and taking out as many variables as possible. So what we're doing today is we're looking at just a couple examples because we've done a whole bunch of them already. Can I ask you for a number that divides into 12 and 21? What's a number that divides into 12 and 21? Yes, Liana.
3.
The answer came in class that 3 divides into those. So we'll take out a 3. My preference is whenever I see a negative in the front of the parenthesis, I personally like to take the negative out. So I would take out a negative 3 because it's leading with a negative right here, leading with a negative. So when it leads with a negative, I like to take out the negative. That leaves me with the following. 3 times 4 is 12. Negative 3 times 4 is negative 12. 4n minus 7. Okay, thank you for that. So let's keep going. So that's going to be the first one. Negative 3 times negative 7 will, of course, give you 21. Okay. So now let's go to question 7. What's a number that goes into those 3 numbers? Yes?
5.
5 is the answer. So the greatest common factor is 5. My question is, do they all have a variable that could be taken out from these guys? Do they all have a variable to give? No, they don't. So we're just going to divide all of these guys by 5, basically. Divide by 5, divide by 5, divide by 5. So we're going to have 2, the variables don't change, n to the third, because we didn't take any out, minus 1n plus 5. Okay, let's look at 9, slightly different problem. What's a number that goes into 15, 15, and 20?
5.
5 is the number again, so 5 comes out. Now we talk a little bit about variables. I want to look at this. We have 4 k's here, we have k to the 5th here, we have k to the 6th. 4 k's multiplied, 5 k's multiplied, 6 k's multiplied. How many k's? Can they all take away a k? Can they all lose a k?
Yes.
Okay, so we definitely can take a k out. Can they all give away 2 of their k's?
Yes.
Can they all give away 3?
Yes.
Can they all give away 4?
Yes.
Can they all give away 5?
No.
We're going to take away 4 k's, k to the 4th. There are going to be no k's left. He's lost all his k's. He is going to have 1 k left, so he's going to be 3 times 5 is 15. K to the 4th times k is k to the 5th. And 4 times 5 is 20. K to the 6th, well, k to the 4th times k to the 2nd. So we lose 4 k's from all of them. 4 minus 4 is none. 5 minus 4 is 1. 6 minus 4 is 2. Last question. We're going to keep it extremely short today. We're doing the distributive property in reverse. What's a number that goes into all those numbers?
4.
4 is right. What's another number that goes into all of them?
2.
Yeah. So 2 or 4 is our decision because these both work. But my question to you is, what's the greatest?
4.
4. So we use the greatest common factor. And I showed you that this led off with a negative. So because this led off with a negative, we're going to start our thing with a negative. That's just a general rule. And that means we're going to take out negative 4. Can they all lose a p? Do they all have 1 that they could drop?
No.
Well, the first one does have 1, right?
Yes.
So they all have 1. Even though there's not a 1 here, there's 1. So we can take out 1p, but no more. That leaves us with 4p times 1 is 4p. This is going to be negative 5. P. 2 p's take away a p. This is going to be negative 5. P to the 2nd, because we lost the p. P times p squared is p to the 3rd. Negative 4 times negative 5 is positive 20. Negative 4 times negative 4 is positive 16. And p times p to the 4th, because he lost 1, is p to the 5th. So if you distribute any of these answers, you should get back to the original problem. And that's really all we're going to be doing with this particular section. It's called factoring out the greatest common factor. So thanks for watching, and we'll see you in the next video. Peace.